Okay, so everybody, that's about 2 minutes after the hour, so we'll go ahead and get started here. This is Greg, and we've got a pretty good list of folks on right now. I don't think we need to go through any roll call or anything, but you can kind of see who's on here on the attendee list. We've got about 17 people with it, and I suspect a few others will start connecting here in the next couple minutes. But Laura has indicated to me that the presentation is a fairly long one. I think I had scheduled us, at least in my email, for about an hour, and I think it's going to take every bit of that. Just in case, I think the actual go-to meeting is set up for about an hour and a half, so I think we should be all right, and hopefully we won't need that extra time. But you know, it always depends. I mean, there's certainly lots of questions and feedback, and so we'll see how that goes. But we are, just to let everyone know, we are recording this, and then at some point in the near future, after we have a chance to go through and edit and whatnot, we'll go ahead and get it posted. And then for those who were not able to connect or came in late or whatever, we'll be able to access the full webinar. So, a Snow and Ice Environmental Best Practices Manual. This is Laura Fay's project out of WTI, and I'm just going to go ahead and turn it right over to her so that she can get going on it. Laura?
Great, thank you, Greg. So I'm minimizing my control panel for now, so if anyone has any questions, maybe hold them till the end, write them down so you don't forget, and we can always come back to the different slides. So as Greg mentioned, it's a pretty beefy manual, and so a pretty long presentation, and I will do my best to present it in a timely manner. So here we go. So this is the final report presentation for the Snow and Ice Control Environmental Best Practices Manual, and this is a culmination of work by folks from WTI, Washington State University, Monte Vista Associates, and Venner Consulting. Sorry. So just a quick outline. I'll go through the introduction to the topic. I'll review environmental best practices used to incorporate into snow and ice control operations. We'll provide a summary of snow and ice control environmental best management practices, and then we'll review the conclusions that were provided. So an introduction. The objective of this project was to analyze and make comparisons of the impacts of abrasives, chlorides, acetates, formates, glycerols, glycols, and organic byproducts, and to compile the current environmental best practices for using chlorides specifically in snow and ice control operations. This report documents currently available knowledge on cost-effective equipment, practices, and strategies that allow winter maintenance professionals to use the right amount of material in the right place in an effort to achieve the triple bottom line of sustainability. Okay, so getting into the meat of the Environmental Best Management Practices Manual for Snow and Ice Control, the first topic we cover is level of service. And level of service, or LOS, is the type of metric used to determine how a road is maintained using winter maintenance practices. Commonly used LOS in winter maintenance operations include when snow and ice control operations begin, the cycle time to complete one pass on a route, pavement conditions achieved, such as bare pavement or clear wheel paths, a road condition achieved within a specific time after a storm ends. Frequently, this is within a couple hours or within 24 hours. A specified travel speed is achieved, and frequently this is return to normal driving speed for that road, or to measure friction values and make sure they're within an acceptable range. At this time, there's no universally accepted or established standard for winter maintenance level of service, but there are a lot of suggested guidelines out there. Most commonly used are bare pavement, or bare pavement in the center of the roadway only. And frequently these are targeted mostly at primary and secondary arterial roads. And this is based on survey responses for this project and work done for Idaho Transportation Department. So moving on to the next topic, we have a chapter on environmental management tools. And these tools are used to systematically assess which environmental aspects of an operation are most significant, how well controlled they are, and how any adverse environmental impact should be handled. Commonly used EMS tools include the Eco Management and Audit Scheme, or EMAS, the ISO 14001, or the environmental performance management tools such as context-sensitive designs or solutions, and the triple bottom line. EMS have quite a few identified benefits, including reduction in the number, type, and severity of compliance incidents with compliance agencies, reduction in pollution and waste, recovered resources or recyclable resources, streamlined permitting and documentation review and approval, more efficient management at all levels from the top down, increased environmental awareness throughout the organization, facilitation of good housekeeping practices because they're defined within the documents, increased employee training, identified corrective action tools, cost savings, generally through reduced fines and material savings, and overall positive public solutions. The next chapter of the manual goes into training. And the importance of training cannot be overstated, as the success of any best practice, a management system, technology, or product hinges on the appropriate implementation by knowledgeable personnel. And here you can see in the photos, you've got tailgate session on the left where we're talking about probably the conditions they're going to see that day. You have in the middle photo a driving simulator where a snowplow driver is practicing in the simulator. And then on the right, I believe that's a photo from a snow and ice rodeo where a plow driver is testing his ability to drive quickly through a course. The benefits of training include, the benefits of improved targeted training for winter maintenance personnel include a reduction in the amount of snow and ice control products used while maintaining or increasing the level of service provided through calibration training using felt principles such as knowing the application risks and actually using them, and overall the impacts of over-application are reduced. For monitoring and keeping records, monitoring environmental parameters and practicing effective record management of snow and ice control products and related procedures can aid in material savings, create a more effective working environment, can increase efficiency, reduce person and equipment hours, and enable cost savings. And generally this is seen as material and time savings. So snow and ice control materials commonly used. We have sand, we have treated sand, which is frequently 10% solid, and this can increase or decrease depending on what type of application equipment you're using and how you're using your treated sand or abrasives. Commonly used chlorides include sodium chloride, mag chloride, and calcium chloride, and these all come in solid and liquid form. There are agriculturally derived products that are commonly beet or corn products. There are also some other products out there from potato co-products and other vegetables on the market. And then there are acetates, formates, glycols, and glycerols. And the last category are more frequently used at airports, but there are some winter maintenance products within this category that are used. But they're definitely not used as frequently as the chloride-based products. So the pathway of de-icer migration into the environment is shown in this graphic. And you can see on the far left, you have your road application of product. And there are two options. The products can either be aerially dispersed or they can run off. And through aerial dispersion, these products can go and impact the air, aquatic and terrestrial plants, and animals. They can impact water quality and soil quality. I'll leave it at that for now. And then here we have a pathway model that shows snow and ice control products. And it's a little more detailed where you have at the very top on the right, you have your snow and ice control material. And then you have your application to the roadway or release during transport or storage. And it shows the different pathways that these products can migrate through the environment, and ultimately where they end up and the potential impacts. And it's important to note that whatever product you put out there, it's going to end up in some environment, whether it's the road environment or the near road environment. So facility management. The design and operation of maintenance facilities can have a direct influence on potential contamination issues and loss of material. Facilities can be the single greatest source of loss of material, and therefore it's very important to keep track of how you're storing your materials and containing them. This can be done with good housekeeping practices by keeping clean, organized, and well-maintained facilities. And along the bottom, you can see some examples. On the far left is an example of the 10-foot rule, which we highlight in one of the case examples. This is reported by PennDOT and the Penn Turnpike, and they use this for all their self-storage. They have a line drawn on the ground, and they're not allowed to store any chloride-based material past that 10-foot line in order to reduce product loss. And then on just to the right one, we have a picture of some tire storage, and these are waste tires from their equipment, and they store them so that they can be disposed of properly. We then have one further right, we have another solid storage facility where we have someone loading material on an impermeable surface, which is another good housekeeping practice. And then on the far right, we show a solid storage facility with a liquid storage tank outside. And again, this is a nice clean facility. It's well maintained. These are all things that we should all be striving for. So for material storage, snow and ice control product storage facilities have the greatest potential to impact the environment because they are a single source that can release a high concentration of runoff to the environment. And for this reason, solid materials should be covered and stored on an impermeable surface, ideally with a door that can close, but this isn't always the case. And liquids, actually I'm going to go back to solids for a second. Solids, so this is salt, sand, or salt, or any other solid product. It doesn't matter what percentage of salt you have added to your sand. If it's 1% salt sand, it should be treated as a salt product. It can still leach to the environment. So it could be 100% salt or it could be 1% salt, but it should all be covered and stored on an impermeable surface. And that was a best practice identified by Washington State DOT. And liquids should have secondary containment and be stored on an impermeable surface. Secondary containment is listed as a double-walled poly tank or a berm or a dike around the storage containers. If you are using a double-layered tank, we recommend secondary containment outside of that anyways, because if a fitting or a hose breaks, that double-walled poly tank will not capture that loss of material. So loading and handling products. Handle products as few times as possible, and this helps not only with eliminating loss of material through spills, but some of the products you want to maintain a certain grain size, specifically with some of the salts, and every time you handle it, you actually reduce potential grain size. So please keep that in mind. Load and unload in buildings as much as is possible or outside on the apron on an impermeable pad. Try to use loaders or conveyors to put the product into the buildings. Conveyors have been shown to be the most effective and cost-effective tools, but not everybody has them. But it is something to look into. A recent report published by Ohio DOT just came out with that finding. Please clean up any spills as soon as is possible, ideally right after they occur. And to capture runoff from loading areas when snow and ice control products are being used, and then dispose of runoff properly or recycle it. Some DOTs have sophisticated runoff capturing plans where they can capture runoff when snow and ice control operations are occurring, and then they can have a diversion valve where they can stop capturing the runoff when they know that it's not contaminated. And that's something to look into, and we do report that in the manual. Operational strategies. So snow removal or plowing is the mechanical removal of snow and ice from roadways. and the efficient use of snow removal can lead to cost savings, a reduction in the use of de-icing materials, and improved pavement conditions. So knowing when to plow or how much time you should wait after applying a material to plow can really save you in terms of product savings, wear and tear on the plow, and the amount of time the plows are out. Material selection. Selecting the most effective snow and ice control material for a given road weather scenario and the most efficient application method to minimize loss of material, cost, and application rates and frequency of application are key to appropriate material selection. So relevant parameters for material selection. Here we have kind of an overview of what an RWIS system will capture. An RWIS is a road weather information system. And the environmental parameters captured include humidity, rate and type of precipitation. Some capture water content of snow. Otherwise, this can be captured manually or through SNOTEL sites. Air temperature, pavement temperature, solar radiation, and wind speed and direction. But other factors that can influence the type and frequency of plowing and application of materials include the pavement type, the pavement texture, and the pavement condition. So application strategies include pre-wetting solid material. Pre-wetting is adding liquid to products or abrasives at the stockpile or at the spreader. Here you can see a photo of pre-wetting where a liquid is being added to a solid salt, and then it's at the spinner and being put out on the road. And the benefits of pre-wetting include ease of product management and distribution, the accelerated breakup of snow and ice and enhanced melting on the road surface, minimization of bounce and scatter and improved performance of the product, and increased longevity on the road and less frequent application. And a great report put out by Michigan a few years ago shows clear material and cost savings using pre-wetting. The use of anti-icing is another application strategy. Anti-icing is, clear that bubble. Anti-icing is the snow and ice control practice of preventing the formation or development of bonded snow and ice by timely application of a chemical freezing point depressant. And it's important to note the function of anti-icing. You're putting product down ahead of the storm, usually a liquid product, to prevent the bond from forming. And this will ultimately ease and aid in plowing. Anti-icing has been shown to improve level of service, decrease the amount of product needed, decrease the amount of abrasives and plowing needed as well. Typical anti-icing application rates range from 10 to 40 gallons per lane mile. And again, anti-icing has been shown to provide cost savings, improve mobility and safety. And ultimately, the side benefits of all this include reduced impacts to the environment, infrastructure, and vehicles due to reduced application rates. There are a few limitations to anti-icing, and it's important to know these if you're going to use this practice. In certain cold temperatures, you need to be very aware of your product limitations. Certain products only work down to certain temperature ranges, and if you're going to be applying them outside of their functional temperature range, you're going to have to put a lot more product out there or let it sit on the road surface a lot longer. You should avoid applying these liquids in rain or sleet as they'll get washed off the road, or in blowing snow, especially in cold conditions like we have in Montana and Wyoming. Anti-icing can actually cause blowing snow to stick to the road. And then there have been a few situations where in certain conditions where air temperature is above freezing and rising with high humidity, there have been reports of reduced friction due to use of certain products. So product application rates. So this is very important when you're considering the type of product you're using and how much product you want to put out to be effective with it. So sander abrasives, reported application rates range from 100 to 1,000 pounds per lane mile. This is a huge range. Use of abrasives can be used at freezing temperatures or colder, and there are certain sites and conditions where use of abrasives is very acceptable, but we recommend in general that the use of abrasives should be limited to only where they're needed. Salt sand or that salt sand blend usually at about 10%, which was discussed earlier, application rates range from 400 to 1,000 pounds per lane mile, and the temperature ranges are a little more limited, and this is a function of the salt and wanting to capture some de-icing from the salt. The use of chlorides, or specifically sodium chloride, the functional temperature range is 32 to 15 degrees Fahrenheit, and this is important if you're using salt or rock salt or salt brine. So solid application or de-icing, typical application rates range from 100 to 800 pounds per lane mile, whereas anti-icing or liquid application rates are as low as 10 to 40 gallons per lane mile. And pre-wetting application rates, so this is pre-wetting of sand or usually solid rock salt with liquid salt brine. Application rates range from about 8 to 20 gallons per lane mile. And for mag chloride and calcium chloride, you can see the functional temperature ranges associated with those. And generally, these products work at colder temperatures. Again, solid application rate for de-icing with these products is about 100 to 500 pounds per lane mile. Solid mag chloride and calcium chloride are not used as frequently as solid rock salt. But frequently, these products are used for anti-icing or liquid and applied at about 10 to 40 gallons per lane mile, or for pre-wetting at 8 to 20 gallons per lane mile. So material application equipment. Material distribution systems allow for application of the right amount of material in the right location at the right time. And newly purchased vehicles have enhanced capabilities to improve treatment efficiency or reduce material usage. And here you can see some photos at the bottom of the page of, on the far left, some stream nozzles for anti-icing. We have a zero velocity spreader or a ground control spreader. We have some liquid spray nozzles, and then we have a slurry application, which is a 70-30 application of solid and liquid. So common material application equipment includes tailgate spreaders and reverse dumping spreaders, multiple purpose spreaders, rear discharge spreaders, zero velocity spreaders, dual spinners, regular spinners, modified spinners, and then homemade variety chutes and spinners. Most application equipment will have some challenges, and these include mechanical failure, clogging and freezing, corrosion, and the need for frequent calibration. And these are unique to each type of technology that you're using, and will need to be worked out kind of on the fly as you go. So tailgate spreaders and reverse dumping of dual dump spreaders. The benefits include they're a multi-purpose spreader that can be used year-round, but the challenges include that they are heavy and that you need to raise the body, which can reduce the stability of the vehicle. Rear discharge spreaders are designed to pre-wet, and generally they pre-wet a fine-grained salt. And they can pre-wet at the spinner or at the hopper using an auger or both. And these can include that slurry application I was talking about, or high ratio application, so 30% liquid to 70% solid by weight. And it comes out an oatmeal consistency, and folks have found this to work really well as a pre-wetting practice. But this practice of high ratio or slurry application does require a larger capacity of liquids, and larger tanks and pumps may be required. Here's some more information on the slurry technology. So the liquid, instead of being added at about 8 to 20 gallons, they're added at about 60 to 90 gallons per ton. And frequently the product's applied at about 200 pounds per lane mile, and that equates to about 9 gallons of liquid applied per lane mile. And here you can see some photos of some slurry technology. So lessons learned for slurry technology includes that 3/4 inch salt allowed for smaller grains to work better. And initially, starting with a heavier application seemed to work better, followed by smaller or less frequent applications once the product is activated on the road surface. And some equipment has worked better than others, and this may be due to onboard crushers or the type and grain size of salt you're using, and there's specific reports referenced in the manual and out there that discuss these specific issues. Material and cost savings were conducted for slurry technology by Maine DOT in 2005, and it's a great report to go back to if you're looking into this technology. And anecdotal comments include that slurry technology works to make the product go into action quicker, probably because of the higher liquid content. Folks said that it acts immediately, lasts on the road longer, and outperforms traditional pre-wetting methods and reduces bounce and scatter. Again, these are all anecdotal comments and have not been validated necessarily. Other application methods include rearward casting spreaders, or these are your ground speed control or zero velocity spreaders, where material is discharged rearward at the same speed as the spreading vehicle is traveling forward. And this keeps more material on the road where it's placed. And application speeds should not exceed 35 miles per hour, as higher speeds reduce application accuracy. And this was found also by the report done in Michigan for pre-wetting. They found that ideally plows should be driving, or application vehicles should be driving, about 25 miles per hour if you want to maximize the amount of product that reaches the road surface. And driving up to 45 miles an hour can significantly reduce the amount of product that lands on the roadway. Another important component to application are electronic spreader controls, and these can be preset or on-demand application rates. And these use electronic ground speed controls to provide consistent application rates. And they can be linked with various sensors on the vehicles, including friction, AVL, and GPS system. Modern units can record information about the application rate, the gate position, the run time, any blast information, such as a single blast of, say, 1,000 pounds per lane mile, and the average spread width and symmetry that can all be used in your monitoring and record keeping for application rates. So equipment calibration is its own little section of the manual, and we like to emphasize equipment calibration. It's a must, and it's a must to realize the savings gained from the investment in the new technology, usually the investment in pre-wetting or spreader-type technology. And it's important to train how to calibrate and how to keep records of calibration. And when to calibrate is very important. Frequently, folks calibrate about once a year, which is great, but ideally, equipment will be calibrated when it's first acquired, multiple points throughout a season, say before the season begins, maybe mid-season, and then towards the end. Whenever a new material is used or after repairs, or if there appears to be a discrepancy in material usage, whether it's by a certain driver or just a certain vehicle in general. It's also important to note that for every different solid you're using, whether it's rock salt or salt sand or sand, those each individually need to be calibrated. And that goes for liquids as well, whether it's salt brine or salt brine with a ag-based product added to it or mag chloride. Specifically for the liquids, the viscosity of them can vary, and this can impact the application rate. Vehicle washing. So low pressure, high volume wash to remove salt and abrasives is the new recommendation that's come out based on the corrosion manual that's being published. Wash vehicles indoors or where water can be contained or captured, and then properly dispose of the wash water for reuse, or in some cases for some state DOTs, they're able to use it to make brine to use for winter maintenance operations or for dust control in the summer. So a summary of corrosion prevention, and these findings come from the corrosion manual that was recently put out by Clear. So corrosion prevention programs may involve the use of salt removers or neutralizers, together with routine washing, protecting of electrical components by sealing or removing them, or moving them inside the cab, reapplication of post-assembly coatings as is necessary, using spray-on corrosion inhibitors, and making operational changes supplemented by corrective maintenance practices to minimize the negative impact of de-icer corrosion to equipment assets, as well as track data relevant to direct costs of de-icer corrosion to equipment and direct benefits of countermeasures. So how much did it cost to rehab a vehicle versus how much did it cost up front to get a more effective coating on the vehicle versus correcting it after corrosion set in. And ensure compliance with these procedures and practices for vehicle inspection and operation and staff and contractor training. And this is really important, and a corrosion prevention plan may want to be set up within each organization on how to assess vehicle corrosion and identify maintenance on a timely schedule. So weather and pavement equipment and technology reviewed in the manual includes RWIS, or Road Weather Information System, MDSS, or Maintenance Decision Support System, and FAST, the Fixed Automated Spray Technology. RWIS is real-time road condition information. Essentially, RWIS is a weather station along the side of the road that provides information that allows for forecasting of the pavement surface instead of a weather forecast for the atmosphere above the pavement. RWIS can be used to time treatments and determine which treatments can be used. And this may be really important if you have a pavement temperature sensor and you have a varying suite of products that you could use. You can tailor your application to the exact conditions that are present. The benefits of RWIS have been well studied and have been identified to be an increase in the level of service provided, cost savings, aid in maintenance response, and increased efficiency. And as I mentioned, multiple studies have been done on RWIS and its effectiveness, and cost-benefit ratios have been reported as 1.4 up to 11, so significant cost savings. Road Weather Management Decision Support Systems, or MDSS. It's tools that integrate road weather forecasts, coded maintenance rules of practice, so this would be your level of service guidelines and your application rates, resource data to provide recommended treatment strategies. It's a software application, and it provides weather forecasts and predictions, road weather reports, and can be used as a training tool before or after an event. The benefits of MDSS include cost and material savings, and benefit cost ratios have been determined to range from 1.3 to 8.6. And another side benefit identified is less use of vehicles, or I guess I should say more efficient use of vehicles that have MDSS on them. Lessons learned from use of MDSS include time needed to refine the forecast. So this is the transportation agency working with the forecasting, usually a private forecasting company, together to really refine what's going on in their local area. And they identified that it's important to get management on board and to continue training and exposure of staff to the MDSS system. The FAST system, or the Fixed Automated Spray Technology, is used usually in pavement. Well, it's used in pavement, sometimes on regular roadways or on bridge decks. Here you can see a picture of a FAST system spraying. The benefits of FAST include reduced mobile operations, and these are frequently located in hard-to-reach or rural areas where a vehicle may not be able to go out and apply material as frequently, or in areas where there's a higher crash rate. And the FAST system has been, the benefits of the FAST system also include reduced crash frequency and delays due to crashes, and reduced material use. But the caveat here is there have been some challenges with the FAST system, and that includes activation frequency and highlighting the importance of system maintenance and training, and that installation of the FAST system should be site-specific and should be well investigated before they're put in. Colorado DOT has had a lot of success with the FAST systems, but they were very on top of their maintenance and training of staff, and they were very specific about where they wanted their FAST systems located. Friction measurements are an indicator of road condition, and they can be used for monitoring, planning, treatment strategies, and prevent over-application of material. On the right-hand side, you can see 4 different options for measuring friction. You have the non-invasive sensor up on the top. You have the hand-measured friction tool. And then the third down, you have a mobile friction measuring device. And the last one is a fixed wheel, which is a tow-behind trailer, and that's most commonly used at this point in time next to the non-invasive friction sensor at the top. So friction can be used to assess performance measures. It's been completed in Colorado. They're using the non-contact friction measurement device, and they've noticed the difference in product performance just by measuring friction at different intersections, and have found that friction data provides good short-term and long-term assessment of product performance, and they were able to actually alter their application rates and their application strategies based on the friction data. Residual chemical measurement. Salinity sensors have been used to make educated decisions about reapplication, and we have an ongoing project with Aurora at this time investigating various salinity sensors, and I think the field data will be collected this next winter and will be ongoing, so I guess maybe in about a year more information will be out on this. But for now, salinity sensors can be used to monitor road surface, product concentration. They can be on vehicle, embedded in the road surface, or non-contact. They're fairly accurate and can be recalibrated for various application rates, and some can be used for various product types, not just salt or chlorides. These measurements ideally can be linked with an automated spreader controller, and the benefits include prevention of over-application, reduction in the use of material, so material savings and ultimately cost savings, and reduced impact to the environment. Other sensors include pavement temperature sensors and thermal mapping, and these can be used to monitor, plan, create treatment strategies, and for creating your pavement forecast. And these can be invasive and non-invasive, as in shown here. On the top right, you have a non-invasive sensor, and then in the bottom left, you have an in-pavement sensor that is considered a invasive sensor. And these sensors are frequently used in spring to open and close roads to avoid damage, as is shown in the middle photo from trucks driving on a paved surface that got torn up due to freeze-thaw cycling. Another technology includes millimeter wave radar sensors. This technology is used to assist snowplow and vehicle operators in their ability to detect objects located in front of, to the side, and behind vehicles. MWRS is the most promising collision warning system in use, and can save ultimately time, money, and improve safety for the driver. Laser wavelength road condition sensors, or LRSS, are a non-invasive sensor that detects road surface condition. These are stationary and they cover a specific range, as is shown in the top right picture. So you have basically a 10-foot by 12-foot square that it can report on. And it can report on dry, snowy, icy, or wet conditions, and reports the percent area for each condition, as is shown in the bottom photo of ice or snow on the road surface. And this can ultimately be used to help plan your treatment strategy and products used, and knowing when to head out and plow a road. Smart snowplows. These are the integration of available technology for snowplows with winter maintenance operations to create a trackable, automated system. And ultimately, this is the future of winter maintenance. It's integrating all of this information that we're collecting to aid in decision-making. Post-storm operations. So post-storm operations for winter maintenance include continued maintenance to achieve the level of service that's defined for that roadway. It can be used to assess current conditions and prepare for forecasted future conditions, and it may include pavement sweeping, cleaning out of ditches, catchments, and culverts, and ultimately preparing the roads so that you're ready for when the next storm comes. So in general, a summary of environmental best management practices for snow and ice control include cover and store snow and ice control materials on an impermeable surface and use secondary containment for liquid products. Regulate the application of snow and ice control materials to prevent over-application, and use specialized equipment to apply the right amount of material in the right place at the right time. Use the appropriate snow and ice control materials for the given conditions, and this is important for if you're using certain products to know what their limitations are. calibrate equipment as frequently as is needed and track this information, and train operators in proper application, calibration, and cleaning procedures. And ultimately, use good housekeeping practices, keeping a clean, organized, and well-maintained facility and equipment. With that said, I'd like to acknowledge the Clear Oath Technical Advisory Committee for their input and help creating this document. Colleen Boss and Greg Wadley with CTC and Associates for their project coordination and management. WTI colleagues that helped in the editing, review, and creation of graphics. And everyone who participated in the survey and follow-up interviews. A huge thank you for the time and effort that went into that. And with that, I will take any questions.
Laura, this is Brian Byrne from Maine. Just wanted to say great job. I think you and your team have done tremendous work with this, and this is going to serve as a really good benchmarking and reference tool, I think, for snow and ice in general.
Well, thank you.
This is Scott Lucas with Ohio. I had a couple of questions. One of the slides you mentioned about using loaders and conveyors to load the material. Were there some, that was a suggestion. What other kind of things were you looked at to load material, or suggestions that weren't really recommended?
So the report that we used for the bulk of that section was recently, actually the final report presentation was just given, I think, a month ago by Ohio University. And basically they did a big survey of everyone in the U.S. and they asked them what they're using for loading product into the storage facilities and then into the vehicles. And most commonly folks were using loaders. And there's a benefit to using a loader because it's a multi-use tool. But what they found was that for folks that are using conveyors, it was the most efficient way to transport the salt and put it where they wanted it and to maximize the use of the storage facility. And that's really why we're recommending using a conveyor if you have one or if you can share one with another facility located close to you.
Oh, okay, yeah, that was our study. I guess I didn't realize that that's what you were quoting from. That's great on that one. The other thing I guess I was going to ask you about was you mentioned sensors to detect levels of salt on or salinity on the roadways. Did you find any kind of sensors that could actually select or sense the levels of sugars on the right of way, in particular like the agricultural byproducts, how much is really on the roadway?
Right. So we're in the thick of the project with Aurora right now. There is one sensor that we've identified that can identify various product types, but it doesn't do it directly. It actually measures the freezing point of the chemical on the road surface, and then you can relate that back to the product that you knew you applied. And they've tested it for some ag-based products and some chlorides. At this time, there is no test that I know of that can say, you have applied 100 gallons per lane mile of beet juice. That is a recommendation we did put into the Aurora group, and they're considering it for a future research project. Okay,
well, thank you. And the final question I had was, you mentioned that one of the ways to prevent over-application was to regulate snow and ice materials. What did you mean by that, or what was meant by that? I didn't quite understand that.
I think the finding is that while most state DOTs have a really reasonable range of application rates, it's training your staff to use those application rates and reinforcing them by calibrating the equipment to make sure that you're actually achieving those application rates for the identified conditions.
Okay.
So it's
well,
really getting people to use the guidelines that are already in place.
When you said regulate, it made me think of EPA regulations and have like restricted materials. That's what kind of scared me a little bit. But yeah, okay, I see what you're saying now.
That. Yeah.
Okay.
Yeah.
Thanks a lot. Appreciate it very much.
Yeah.
Hi, Laura. This is Faide from MnDOT. I'm just wondering if MnDOT was involved in the survey, because I remember from my time in maintenance, the MnDOT maintenance folks, they had a lot of different kind of homemade chutes and modified spreader, and they have good results from that. I don't know if they share those pictures or those experiences in this report.
We did get quite a few responses from Minnesota on the survey, and thank you to everyone. The survey actually only asked, I think, one question about material application equipment in terms of what is most commonly used. So it was really at the whim of who responded to the survey. And then in terms of getting pictures, I don't believe we did a case example interview with anyone regarding spreader equipment for this project. And I think that's probably the only way we would have captured all of the various application equipment. But there are quite a few reports out there on all the different application methods and strategies and kind of the in-house application equipment that's been created.
Okay, thanks.
Any other comments or questions?
I guess I did have one more then for Ohio. You did mention about the different slurry generators and that, and I know I think it was referred back to Maine. I know Brian's on the line as well, but that you said that the consistency was like oatmeal coming out of it. We test like EPOC system, and the system at least we have, I don't know if we had the wrong model or something like that, but it doesn't seem like oatmeal. It seems just like a real heavy volume of brine on the salt. But had anybody found it actually is like more of a pasty material?
Okay. Well, maybe it's a semantics. I think Monty Mills was.
I can weigh in on some of that. This is Brian again in Maine. Yeah, that really depends pretty heavily on what your gradation is in your salt. If you have the finer gradation with that pre-wetting rate, then you can get into more of the oatmeal thing. I think where we found it, we've got a coarser salt, and that was some of the issues that we were having with getting exactly what they were talking about in Europe. But it was more of like almost like a brown sugar kind of a consistency sort of a thing, you know, where it had a lot more moisture than our normal trucks or our typical trucks. But then, you know, with the coarseness that we had in our salt, we didn't quite get to the full oatmeal level too, you know what I mean? So.
Okay, thanks a lot, Brian. Appreciate it.
Yep, sure.
And I don't know if folks can see the chat box on the GoToMeeting panel, but Justin posted a link to one of the material distribution reports that's on the Claros website. So you can click on that link to access some of that Faraday. All right, any other?
Go ahead.
Oh, in the chat box of the GoTo panel, if you click up and down on the arrows, you can see a link to a Claros report on the comparison of material distribution systems that Justin posted, and you can follow that link to get more information. All right, any other questions or comments? Well, while folks are thinking, I'll just let you know that I was asked by the TRB Committee on Transportation Sustainability, ADC 60, to present at their workshop in early June, and I did present for about 20 minutes on this topic, and it received a lot of interest, and so that was good and exciting. Folks are happy to see that this manual is coming out. Additionally, I asked permission early on from the Claros panel if I could submit a paper on this topic, and the paper was accepted to ASCE Journal, and I'll be presenting that summary paper on this topic at the CESTIC workshop this summer in Fairbanks, Alaska in August, if anyone would like to attend. And additionally, I was contacted by Roads and Bridges magazine, and I think someone from Clear Roads notified them, but they'll be running an article on this manual, and hopefully that'll be published in the next issue.
Yeah, that's great, Laura. This is Brian again. I also got a call from the Roads and Bridges fella, and he interviewed me on some of this as well. So that seems to be going well.
Good.
Yeah.
Brian, this is Caleb. I'll make sure I have a copy for you to autograph next time I see you.
Has it come out yet?
I know. I'm saying when it comes out next time I see you, I'll have you.
Oh, okay. Yeah.
Greg, is this already on our website, or when will this be posted on our website?
I think that depends on final approval needs to be granted by the project panel, and then
Right, okay.
I guess I'm not sure if Brian or Greg can answer that.
Yeah, just because I'm thinking if we're going to, I mean, it's great that we're going to get out and get all the press and everything out on this, but then people are going to want to see it. So.
Right.
Yep.
Right. Greg, I don't know if you're on the line.
Yeah, it's a real good point, Caleb. Yeah, Greg, this is Brian again. I'm not positive what the final formal step is for the committee. Do we take a vote here? Do we set up another subcommittee meeting and then get that done? Or how's that work?
You know, we'll connect offline on this with ourselves and the subcommittee. We'll get the final approval. We'll get it posted, and I will send out a note and a link to everybody on the TAC to let them know that it's out there. So we'll take care of that.
Okay, cool. Sounds good.
Okay. Well, thanks everybody for joining us, and we got you out of here right on time. So everyone have a great rest of the week. And like I said, I will get this information out to everybody once it's posted, so that you guys can start to view it on your own and use it for any dissemination efforts that you might need. So thanks, and we'll talk to you later.